Hello guys, in this tutorial I want to show you the sub-menu of the rectangle command in the sketcher module of CATIA v5. So if you press this little arrow under the rectangle, you can see that it hides other commands, and in this video I want to show how to draw these shapes using two methods. And first I will start with the oriented rectangle. So I select the command, and the first method to draw this shape is by using these fields right here. So firstly I have to introduce the coordinates of my first corner point. So I will start from 0. And now I have to either introduce the second corner point coordinates or the width and the angle of my rectangle. So I will go with the width of 60 millimeters, and I want the rectangle to be oriented at 45 degrees. So I have my width and the orientation of the rectangle at 45. And now I have to introduce either the third corner point coordinates or the height of my rectangle, and I will introduce the height to be 100 and press tab, and this is my oriented rectangle. You can see that I have enabled the geometrical constraints. That's why I have these green lines which signify the parallelism between each opposite segment of the rectangle. So this was the first method, and the second method is by using the constraints command. So I will just draw my rectangle as I want. Okay, and now you can see that I can modify its dimensions when I drag it. I will press the constraints command, and for each side I will introduce the desired value for my segment. So let's say 60 with 70. Okay, and now for example, if I want my rectangle to be at a certain angle oriented, I will use again the constraint command. Oh, sorry. So again, the constraint command selected, and I will define an angle between this side of my rectangle and the horizontal line, and I will select, let's say, 30 degrees and press enter, and this is how I drew my rectangle just by simply drawing it on the working area and then applying constraints on it. Moving on, now I will show you how to draw the parallelogram. So this is the command. I will select it, and with the first method I will go with this fields right here. I will fill them up with the coordinates. So again, I will start from the origin. Okay, so now I have to to establish the width of my parallelogram, I will select a width of 60 millimeters at an angle of 70 degrees, and now I have my width drawn, and now I have to either enter the coordinates of my third point of the shape or the height of the parallelogram and the angle. So I will choose a height of 70 millimeters, and now I want to select the angle. So let's say an angle of 50 degrees, and this is my parallelogram. Okay, so this was the first method, and the second one, I simply draw as I wish my parallelogram, and then by selecting the constraints command, I put dimensions on my segments, and I also dimension the angle between my two adjacent segments, and I simply introduce my desired values, 60 and let's say 80. Okay, and this is my my parallelogram. If I want, for example, to orient this parallelogram with respect to my coordinate system, I have to put an additional constraint between, let's say, the horizontal and this segment, and you can see that it already detected the angle, and I want to be at an angle of let's say 20 degrees, and there you have it. So this was the second shape. The next command is the elongated hole command. So first I have to introduce the coordinates of my first center, press tab, and now I have to introduce the coordinates of my second center, or the length and the angle of my elongated hole. So I will choose the length of 60 millimeters at an angle of 30 degrees. Press tab, and now I have to introduce the, either you can call it the width or the radius of my shape, because it is the same. So I will choose a radius of 20 millimeters and press enter, and this is my elongated hole. So first I had to introduce the coordinates of my first center, then the coordinates of the point of the second center, and then the radius of my elongated hole. Okay, so this was the first method, and the second method, you just simply draw the axis, the symmetry axis of your hole actually, and after you have drawn it, if you drag sideways your cursor, you can see that it will automatically draw your profile, and you can press click wherever you want. And now, using the constraint command, you can dimension the distance between the centers and the radius of your hole, 25. Okay, so this was how you can draw the elongated hole. Moving on with the cylindrical elongated hole right here, I will first introduce the coordinates which define let's call it the symmetry arch of my elongated hole. I will show you in a minute what it means. So let's go 20, 20. Now I have the center. I have to enter the radius of my arch. Let's say 50. And now I have to introduce the coordinates of 2 points which will be located on my arch. Actually will be the end points on my arch, or I can build this arch using 2 angles. So I will go with the angles, the first angle to be 20 and the second to be 60. And this is the symmetry arch I was talking about. So introducing the coordinates helped me to place my elongated hole, and to finish the command I have to introduce the radius of my elongated hole, and I will go with 10 millimeters and press enter. So this is the first method to draw such a shape. And now I will use the second method. I will simply define in a random way my arch and the radius of my elongated hole, and now I will use the constraint command, and I will just a second, I will introduce my desired value of this radius, let's say 30. I can also introduce the distance between these 2 points, and I will go with 40, and also the radius, this radius, I will go with 8. And this is another way to draw this cylindrical elongated hole. Okay, so now I will show you how to draw the keyhole profile, this one right here. So I select the command, and I will first introduce the coordinates of my symmetry line, or the axis of my profile. I will go with 20 to 20, and as you can see it already appeared as a dash dot line, and now I will have to introduce a second point, the coordinates of a second point, or the length of my symmetry line and the desired angle. So if I go with a length of 60 at an angle of 120, I have drawn till now my symmetry line, and now I have to establish this small radius of my keyhole, and this is done by introducing the coordinates of a point through which my profile with this small radius passes. So if I go with, let's say, minus 10, minus 10 with 60, okay, And the same thing I have to do for the second radius. So let's say minus 7 with 30, and this is it. This is my keyhole profile. So this was the first method, and now I will show you the second method, which I prefer more. So I will simply draw my symmetry line, then the small radius and the larger radius. And now by using the constraint command, I can dimension the symmetry line, its length, let's say 40. I can dimension this small radius 6, the larger radius 15, and I can also angle this profile with respect to, let's say, the horizontal line by selecting this symmetry axis and this horizontal line, and this is my angle. So this is how you draw this profile. Moving further with the hexagon command, I will introduce here the center of my hexagon, let's say 30 with 30 millimeters. And now I have to introduce the coordinates of a point which is located on my hexagon, or the dimension of one segment and the desired angle. So if I go with the dimension and I introduce 50, and now I introduce the angle of 25, there you have it right here, the hexagon. So this was the first method. The second one, using the constraint command, after I have drawn randomly my hexagon, I will introduce the length of the segment and also the angle, let's say between the horizontal line and this line, which is, let's say, 20 degrees, and this is my hexagon. You can see that the software has already auto constrained my shape because I have activated this geometrical constraint tool, and I just had to introduce the length of one segment and the angle between the horizontal line and this line, which is a line starting from the center of my hexagon and goes perpendicular on one segment. So this is how you draw a hexagon with the using the constraint command. The following command is the centered rectangle command right here. So firstly, we have to introduce the coordinates of a point which is located at the intersection of the two diagonals of the rectangle. So if we go exactly in the origin with 0 on horizontal and 0 on vertical, this is the middle, where is the center point located. And now we have to introduce either the coordinates of a second point or the height and width of my rectangle. So if I go with a height of 50 and a weight of 60, this is my centered rectangle. Okay, so this was for the first method. The second one is I will just simply draw the center rectangle, and after that, using the constraint command, I will dimension this side of the rectangle and then the second side. Double click on each of them and introduce the desired values, and there you have it. And finally, the final command, the centered parallelogram. In order to show you this command, I will first draw two intersecting lines, because now when I select the centered parallelogram command, it will ask me to select the first line and then a second line. And the parallelogram will be positioned at the intersection of these two lines. So I have to introduce an ending point which defines my parallelogram, or its height and width. So if I go with the height of 60 and a width of 50, this is my parallelogram. So this was the final shape. If you press the constraint command, you can check its dimensions. Thank you very much for watching. I hope you find helpful this tutorial, and in the next one I will present you the submenu of the circle command with these particularities. Thank you very much for watching and have a great day. Bye bye.